Hello class, today we are talking about section 10.3, which is inscribed angles. Let's start with some vocabulary. First of all, an inscribed angle is an angle, obviously, whose vertex is on the circle and whose sides contain chords of the circle. So if you take a look down here, I've got an inscribed angle. Its vertex is on the circle and its sides contain chords. Now they actually continue on as rays, but they still contain chords of that circle. The intercepted arc will be an arc that lies in the interior of that inscribed angle. It's inside of that inscribed angle. And it has endpoints that are on the angle. Okay. Now, if we take a look at this first theorem, which is talking about the measure of an inscribed angle, it says, if an angle is inscribed in a circle, so I'm going to be talking about angle ADB here. That's my inscribed angle because it has a vertex that is on the circle. ACB, would it be a central angle? It's not going to be the inscribed angle. So if an angle is inscribed in a circle, then its measure is going to be half of the measure of its intercepted arc. Now, for this example, I don't have any numbers, but if I just said I know that its intercepted arc is x, then we know that this inscribed angle would be 1/2 of x. So its measure is half of its intercepted arc. Now, I drew in the central angle here because we've looked at that relationship before. We know that the measure of a central angle is the exact same as the measure of its intercepted arc. So really, we could be given its central angle and know that this was half of that central angle. Or I could be given the intercepted arc, and I would know that this is half of that intercepted arc. The next theorem says that if two inscribed angles of a circle intercept the exact same arc. So here I've got a blue angle, angle ACB, and a pink angle ADB that are both intercepting this exact same arc. So their endpoints are the endpoint of this arc are right on those angle measures too, on the sides of that angle. If they intercept the same arc, then those angles have to be congruent. Now again, here's why. If I know that the arc has a measure of x degrees, we know that each one of these, because they're inscribed angles, will be 1/2 x. The next theorem says if a right triangle is inscribed in a circle, again, a figure inscribed in a circle means that its vertices are touching the circle, then the hypotenuse is a diameter of the circle. This hypotenuse here has to be the diameter of the circle. Now, conversely, it says if one of the sides of an inscribed triangle is a diameter, so if one side of a triangle is a diameter, then the triangle has to be a right triangle. And the side opposite the diameter would, of course, have to be that right angle. Now, you may be thinking, I'm not sure I get that one. So I want to make sure we understand and we can break this one down a little bit. If you take a look at this right angle, we're saying that this is going to be a right triangle. If this is a 90-degree angle, if we look at its intercepted arc, we know that this measure is half of its intercepted arc. Its intercepted arc would have to be 180. Well, the only way that that's going to happen is if this is inscribed, is if we're looking at the diameter itself, if we're looking at half of that circle. So again, by having that one side be the diameter, then that forces this to be 180 degrees. It's half of that circle, which again, if that's 180 degrees, we know that inscribed angle would be half of that, would be 90. So this can only be a right triangle if we know that that diameter of the circle is the hypotenuse of our right triangle. The last one talks about a quadrilateral, so four-sided figure, can be inscribed a circle if and only if its opposite angles are supplementary. Again, think about it. What do you know about these two angles together? Well, let's look at their arcs. They're both inscribed angles. This arc and this arc together would equal 360. Well, these are each half, so therefore those are each going to be together, I shouldn't say each, together those are going to be 180 degrees. All right, and that's true for either set that you look at because you know that they're intersecting at these vertices, so when I put them together it's going to be 360, so as I look at those angles, half of that together they'll be 180 degrees.